enough yet. Embedded RFID and tires and everything that we can find out about that. Let's hear it from Randall Grain at from HANA RFID. Good morning. So I said good morning because you're broadcasting from the US?
I am. We are based out of Twinsburg, Ohio, which is a little outside of Cleveland.
All right. Then we would hand over the moderator rights to you now and get going.
Great, we see your screen. You're good to go.
Perfect. All right. So as you mentioned, I'm going to be speaking on embeddable RFID tags, specifically RAIN RFID. So just a little bit about HANA Technologies. We are located, as I said, in Twinsburg, Ohio. We are a part of the HANA Microelectronics Group. And we've been working with RFID since the early 1990s, and we've been doing that in the US since the 2000s. And we're currently producing RFID in about 4 different facilities worldwide. The HANA Group is headquartered in Bangkok, and we have a revenue of 775 million and about 10,000 employees globally. And as I mentioned, with RFID, we've been doing that for 30 years. And we also have a well-qualified inlay program through the Auburn certification program. And today we've tagged billions of items globally. So looking specifically at RFID and tires, there's a lot of work that goes into it, and I'm going to delve into that. So the tagging project started in the mid-2000s, and the initial impetus was focusing on electronic pedigree. But as we worked more and more with some of the major tire companies such as Goodyear and Michelin, it started becoming apparent that there was a lot more added value that they could gain from an embedded RAIN RFID tag. Currently, the primary applications are truck, buses, commercial vehicle tires, and racing applications. But based on the feedback that we've seen from the market, we expect that to begin expanding into the passenger and consumer market in the next few years. So when you're looking at putting a RAIN RFID tag with a tire, there's really 3 solutions. You can embed the tag inside of the tire. You can put a bead label on, pre-vulcanization, that will actually get vulcanized to the outside of the tire, or you can add an aftermarket tread label, which is really used for some consumer information as well as inventorying. But comparing the 2 most common types, there is the embeddable tag and the tread label. And the tread label gives some information for the consumer. You are able to print on the label. I know in the EU, there's some regulatory information that you have to put on it. With the embeddable tag, it's more useful for some production information and for the tire manufacturer themselves, as well as the consumer. You can keep that information that's contained via the tag in a cloud database through the life cycle of the tire. So you are able to access that information until the tire is taken off your vehicle and you go into post-life recyclability. So looking at why you'd want to put a tag inside of a tire, well, there's a number of reasons. Looking at the passenger car market, there's some current regulation that's being proposed about the digital passport of a tire. And essentially it's saying that you as the consumer are going to have some responsibility in what happens to the products that you purchase. So knowing what type of materials are maintained inside of that tire is going to be important in the post-life EOL recyclability discussion. Putting a tag inside of a tire is important because anything that's affixed externally could potentially be tampered with or removed. By embedding the tag inside of the tire, you're ensuring that that traceability is maintained throughout its life cycle. And by using RAIN RFID, there's a common ecosystem in place of readers, software, hardware that enables you to use that tag with pretty standard protocols. From the manufacturing side, by using RFID, if there's any type of issue, you can identify lots. It enables you to quarantine or isolate any potential batches that might have had issues. From the logistical side, you're removing a lot of manual operations where you would need to be actually taking a pen and paper and writing down a serial number which takes time, costs money. By using RAIN RFID, that enables you to completely automate that. And it also helps with shipping control and distribution to specific factories or retailers that are going to be using or selling that tire. And then at the EOL, it helps you sort tires based on what materials are in there, and also determines tires that still have some life left in. So making products be able to exist in the market until they are truly fully consumed is also enabled by RFID, because you can look at tires that still have some tread depth left, and they can be used in a secondary market and not just immediately discarded as they are today. And then in the fleet operations, RFID becomes key because they are managing huge groups of tires that in today's day and age, people are really buying tires by the mileage or the kilometers. You're paying for distance rather than just a set of tires as you were in the past. So making sure that you're able to identify that tire and know that you're actually getting the amount of mileage that you signed up and paid for is extremely important. And RFID also enables you to assign the TPMS system with the unique identifier on the tag, and lets you program some of the tire pressure as well as tread depth measurements that you're taking throughout the tires, and keep that in a database so you can monitor, what type of wear and tear is being put onto that tire in the fleet environment. So the interesting thing about tires is if you were to design the worst environment to put an RFID device in, it would essentially be a giant piece of rubber with a lot of metallic contents. And unfortunately, that's exactly what a tire is. So there were some pretty big design challenges that we had to overcome when beginning this project. So looking at the tire, there's some interesting interplay between the tag itself and the tire. And the tire attenuates the tag quite heavily, and that's due to some of the carbon black, some of the additives, as well as the metallic content and some of the canvas plies that exist inside of tires. So when designing a tag, we needed to take all of that into consideration. And we also need to make sure that the tag would be able to withstand the stresses of the environment that I was being embedded in. The tire construction process is that the tag and the entire tire itself is subjected to a considerable amount of heat and pressure, as well as some voltage as well. So we had to make sure that none of that was going to damage or degrade the tag's performance. So, and again, looking at the tag inside of the tire itself, that's one consideration, but then you also have to consider that the tire is going to be assembled onto a wheel, which is introducing even more metallic content into the environment. So that boils down to making sure that you're selecting quality materials, and that is from the IC, the printed circuit board, the material that we are using as a wire antenna, as well as the antenna geometry itself. The spring type antenna design that we have is extremely durable and robust, and it is capable of withstanding the environmental factors that the tag is subjected to during the tire construction process and during the use of the tire. And when designing the tag, we take that from a few different facets. There's a lot of upfront simulation and modeling that goes into designing the tag, but we also do some empirical testing as well. So on our side, we like to actually have tags embedded inside of the tire that we can then put into an anechoic chamber and characterize the tag. After all that's completed, we work quite closely with our tire constructor partners to have them do their own durability testing to ensure that there's no disruption in their quality caused by the tag once it's embedded inside of the tire. And one of the design constraints that you have is the attenuation caused by the tire. So when you're looking at an RFID tag, it does have a specific resonance, and that is the frequency at which you need the least amount of power to activate the tag. But when you take the tag in air and measure it, and you look at it inside of a tire, you'll see it's quite different. So you can see that The in-air resonance of a tire tag like this is roughly double of what it is once it's inside of the tire. So that is a big design consideration that you have to take, in that when you are actually testing the tag itself, whether it's during production to ensure the tag's quality, or on the tire constructor side when they're doing their incoming quality control, you need to make sure that you are replicating a tire environment somewhat so that you can actually bring the tag down into the UHF frequency band that most of the existing test equipment exists in. So on our side, quality is extremely important. Again, working with anything automotive, you need to ensure that quality is of the utmost importance. And because of that, we have automated the vast majority of our production process, from the soldering of the antenna to the production of the antenna. Some of the tags that we produce have a rubber adhesive coating on there to promote adhesion to the various rubber layers that it will be laid between during the tire construction process. And we also do a 100% test on every tire tag that we make, ensuring that you can read the tag, ensuring that you can write to the tag, as well as checking its RF performance as well. So what to look at for the in-tire use, some of the keys to success. Typically the tag is going to be laid between two strips of rubber, and these strips of rubber ostensibly serve as an extension of the antenna. So you need to look closely at the dielectric properties of the rubber, or you can find that they will interfere with the tag's performance substantially. Some of the polymers that have high carbon black, which are extremely commonplace in passenger car tires, we find have a greater interference with the tag's performance. And it's also important to keep it away from metallic structures as much as possible, as these will attenuate the tag further, and direct contact is not advised. So when we initially do the testing with a lot of our tire customers, we will recommend to them that they try different materials to surround the tag in, and they try different embedding locations to make sure that they find the optimal result. And some of the programming challenges that we've had, as I mentioned, the tag doesn't perform well in air. So when we were initially looking at how we were going to do our inline testing, we tried a few different manual loading fixtures that would basically introduce some metallic content to the tag's environment that would simulate the tire to the best of our ability. But we learned that doing this manually was not repeatable and would not be a good long-term solution. So working with our partners at Voyantic, we found a very good system to actually replicate the attenuation caused by a tire and put this in a fully automated piece of equipment that was extremely accurate and extremely repeatable. So the system that we have today is much more elegant than it was 20 years ago when we first started. And if you look to the right, you can see some pictures of some of the inline programming systems that we used. These are 100% designed and fabricated in-house. And all of the tag, from loading into the final shipping format to holding above the test fixture, is completely done robotically. And we do test 100% of our tags for RF sensitivity, read and write functionality. And we also program with a unique electronic product code to make sure that that write function is working properly. So some of the keys to survivability, making sure that you have a mature IC design, as well as the package that the IC is going to be placed in, and picking high quality antenna materials. And as I mentioned before, a lot of the automation that we've introduced has extremely increased our internal quality control and made sure that we're producing the best product possible. The two major form factors that we're producing today are the Gen 3 tag, which features a direct attached antenna to the printed circuit board assembly. This also features a rubber adhesive coating. In the newer design of the tag, the Generation 4, which is a linkless design, there is an IC and a system and package that is surrounded by an outside antenna. And this system and package couples inductively with the outside antenna. So there's no direct mechanical connection between the outside antenna and the chip inside. So it increases the durability and robustness of the tag by removing some of those mechanical connections that were present in the preceding version. So looking to the future, as we mentioned before, the tire tag market is growing. And just some figures, looking at Hana's tire tag volume history over the last 18 years, you can see that in 2015 is when things really started to pick up. We exceeded 10 million units, and that has been growing pretty steadily. And we expect 2023 to be our highest year to date. And based on some of the projections from our customers, this should start to increase dramatically over the next 5 years. And from a capacity standpoint, we currently have capacity for a little over 50 million tags, but the plan is to grow that with the market. As the digital passport initiative gets passed in Europe, and we expect to see some similar initiatives passed in the North America and Asian markets, we think that RFID is going to be governmentally required in a lot of tire applications in the future. So we expect to expand our operations to support that growth and make sure that we are there to capitalize. So as a summary, embedded solutions do work. They've been used for over 10 years in volume, and especially in the last 8 years, getting into some substantial volumes. They can be embedded in any type of tire. And there's virtually unlimited IC options depending on what the unique use case is on a per customer basis. And by automating and producing a well-refined product, we are able to do this in a cost-effective manner as well. So through HANA, over 100 million tires have been RFID equipped, and we've calculated that they've gone an estimated 50 trillion miles without a single field failure. So just doing some math, that's enough to go from here to Pluto 15,000 times without a single issue in the tire caused by the RFID tag. So again, it is a viable technology, and it is present in the market today, and we expect to see it continue to grow. Thank you.
Thank you very much for your presentation and the great end with those amazing figures. We'll go right to the live Q&A session now, and we'll see what questions are in store for you. The first question, do the RFID tags embedded in the tires need to be maintained? If so, how does that work?
So the embedded RFID tag is fully passive, meaning there's no battery. It's completely reliant on the power from the reader in order to communicate. So there is no maintenance required once the tag is embedded inside of the tire. The only maintenance that might need to be done is maintaining your database and ensuring that the information that you're assigning to that specific tag is relevant.
Thank you. Any further questions from the chat? Yes, it seems to be a longer question that's been divided into parts. The first part, are there different kinds of RFID tags for summer and winter tires? The second part, would the RFID tags work in countries of extremely low or extremely high temperatures?
To speak to the first point, no, there wouldn't be a different tag type for summer or winter tires. The tags that we're producing today are pretty well optimized to work in a number of different tire applications. So whether it's a huge earth-moving equipment tire or a small passenger car tire, the technology is equally viable. Going into the temperature range, the only limitation would be the actual silicon integrated circuit itself, which does have some temperature restrictions. There is a operating window that I'm not sure off the top of my head, but I believe they are good down to -20, -40 degrees centigrade without any detrimental or adverse effect to the tag itself.
All right. Thank you very much. Are there any further questions from the chat? No more questions. So once again, thank you very much for your time, for your lecture. And I must say, I really like the tire in the background over there.
Thank you.
But thank you for joining us today and for sharing your expertise in RFID and embedded in tires. It was very, very interesting.
Okay. Thank you very much.
Yeah. Have a great day.
Same to you.